Hello, can you hear me? Yeah. Oh, not yet. Hello, hello. Hi, hello. Okay, sounds good. So, all right, everything looks fine. Let's get started. Um, well, actually, all right. So, yeah, let's get started. Um, so, welcome to this live stream. This is the second videos for going through the Lure's tutorial. Right, so so far we have already go through the getting start guide for the Solar 2D game engine, and I was planning to get started on start writing the game, but I realized, well, let's also go through the Lua tutorial first because we're going to use the language, right? So we want to make sure that we have everything in place, not missing some weird thing. And of course, to me, one of the big questions about the OO syntax, the dot and the colon. In the Solo 2D getting start guide, it have a small paragraph describing what it is, but just want to go through the actual tutorial about that. So in the last video, we have go through the first 13 part of the tutorials as what you've seen here. So from the overview all the way to the tables. So in this video, we will go through the remaining of it. Hopefully we can finish this and then also go through most of the advanced part. So without further ado, let's get started. Um, all right. So yeah, it's a bit cold today at night, so and sorry for the coughing still again, since in winter times I tend to cough, nothing serious going on. So let's go. So modules, right? So in the Lunar 2D videos, when we go through that, we pretty much understand what it is. So this probably would be a quick one. It's more so module like it's like a library that can load using require and has a single global name containing a table. Okay, just meaning the return value. Consists of number of functions available. That's all good. The usage of table in modules help us in numerous ways and enable us to manipulate the modules in the same way we manipulate any other Lua table, and so on. It provides extra feature for which other language needs special mechanisms. Let's see. So we can require, okay. So besides doing, seems like the parenthesis is still optional. And also it's if we do not define a local variable by default, it will put itself into this print formatter, right, which match the name. I think that is the case. And to test that, actually, I would like to take a look at that. Let's see. So let's bring up simulator. Actually, let's open the Star Explorer this time. Right, and then we want to take a look at here. So we have, let's say we have these high scores, right? This is returning this scene. And then over here, I want to say require high scores. Oh no, this is I am in high score. Let's go to say menu. Require high scores and print high scores. Right, and see, let's see what do we get. We get a bunch of stuff. Let's see if that is what we are looking for. Oh no, that's not what we're looking for, because that is this guy. Actually, let's do that from main. It's no. It's no. X equals to require. Let's print that. Okay, yes, this does get a table. So I guess it's the same thing. So this also get the table. But if I don't do that and just say high scores, it's got new. So that's not what what is said over here, right? This is require print formatter, but we didn't get the same print formatter. So let's see scene, because in the high scores, this return is scene. Let's see what do we get from there. Also get new. So maybe this is saying it put the in this Lua file, it put the print formatter as the global variable, and then so you can use it like that, or it set it to that. So at least what we have seen right now, this does not match with what we saw over here, right? So that's that. The require function. Lua has provided a high-level function for require to load all necessary modules, and as keep as simple as possible. That's fine. And so over here, it defines all these functions, right? It defines this object, and then inside this object, it defines all these quote-unquote static function. I don't know how they call it. So over here, you require my math modules and then do the things, right? So that's simple enough. Old way of implementing, we probably can skip it because we're not going to do anything old way. All right, so in summary, the example it gives doesn't match with what we expect, right? It doesn't, that doesn't work, but at least we know when we set to a local variable it's working fine. And of course, we're expecting we will be doing that, right? So that's okay. It's some surprises, but it probably won't affect us. So now, meta table. Meta table is a table that helps in modifying the behavior of a table that's attached to with the help of a key set and related meta method. These meta methods are powerful Lua functionality that enable features like changing, adding functionalities to operators on, oh, really some kind of meta programming. Looking up meta tables when the key is not available in the table using underscore index in meta table. Looking up when the key is not available in the table. Okay, let's see what it means. So there's set and get. My table, my meta table, and set meta table and set it in there. So basically attaching the metadata to the object, to the table. The above code can be represented in a single line as shown below. Yes. Okay, so when you set it, it returns the table itself. So that's what that means. And a simple example of meta table for looking up metadata for looking up the meta table when it's not available in table is shown below. So you do a set and then you specify this with a index, kind of like a getter. So this is a little bit kind of similar to the magic function in PHP, the get magic function. So it's just a hash to goes in and get any additional information from that meta table. Okay, so we get the key and then return this. If not, return that. That's fine. Not too difficult. So let's explain what happened in the code above. So the table is key 1 over here, key 1, but it doesn't have the value key 2, right? So it contains that function and is simply look up if the key is key 2, then it will return that. So we can have a simplified version of for the above to do this. Okay. Interesting. So, well, basically you passing in a table for lookup in case if it's not found. Well, if it's not found, what if it is found? I think what if it is found, this will take precedent. If it is really saying this is a simplified version of this, right? So it will get this key first, and so when it match, it return that. So this will be returned even if let's actually take a look, right? Right, so value 1 meta table value. And so what happened is if I say key 2 equals to B2, right? This, oh, actually it's wrong again. It's only used as the default value. So this tutorial is also not that accurate, right? But oh well, it is what it is. So that's why we have to go through this tutorial and actually trying it out to understand what it is. So when we add new underscore new index to meta table, if keys are not available in the table, the behavior of new key will be defined by the meta methods. Okay, so we have this object. This is a meta table. So get a key 1 and set this as my meta table. And then this set a new key. And then printing that. And also printing that new key. Okay, so let's take a look at what does it show. So the first print is value 1, right? Value 1. The second one, what? It got there. What is this meta table? I'm confused. If it is still a key one which already exists, it go there. So it's not really meta programming or anything. It's just kind of a shadow table to contain additional information, seems like, because this doesn't exist. Well, the original object only has this key 1. So if you put a new key over there, the key 1, well, the object itself still does not see the new key. And the information goes to the meta table. So let me understand. So this is useful to store kind of additional information. So really forget about OO, things like that. This is doing something completely different. So it's for loading additional information. Yeah, so hi there. Yeah, welcome. So QLex, yeah, is that how to pronounce your name? Or ID. So well, right now we are going through the Lunar tutorial at the where we were working on in this meta table. So it's kind of a bit strange, kind of some some feature that doesn't exist in other language. So it's kind of interesting. Hope you enjoy yourself over here. Okay, so let's go back to this. So that is what that guy does. This will capture any new properties that get assigned over here, and it goes to this meta table object. So you see that in the above program, if a key exists, the main it just updated. It doesn't exist, it go to the other one. So if it's using a function style, then it get that my table and it do this raw set. So so this will allow you to kind of do a setter, right? It's kind of a setter thing. So when you set a for to this my table, instead of just set it directly, you're able to intercept it and do some processing and through this raw set. So that's what it does. So I can see probably it will enable you to do some interesting thing, but exactly how to utilize this functionality or this behavior will depends on the program, on the application, on the actual case. So I can't think of anything useful for this feature yet, but probably some other documentation or tutorial will explain that. But for now, it's okay. We just keep this. So keep going. So add operator behavior to table. So all right. So this allow us to add additional functionalities. So let's see. So this is operator, the add operator. So let's see here. Yes. So when it's doing this, doing add, it's do whatever needed. So it's the my table and then the input the new table, and then whatever we want to do about it, we make that happen. So add subtract, multiply, divide, and all those operators, right? So you can override the behavior. So sometimes, so this probably getting a little bit too deep to my taste, because personally, this kind of meta programming, sometimes it is useful, but in a dynamic language, doing this, it could make your code pretty hard to understand, right? Because you have this hidden behavior, and so if it is not used throughout your whole applications and you see this syntax, you will say you probably won't understand exactly what it does, right? So when I work on my application, my program, I typically will stay away from it. But anyway, it have that capability, right? So it also can make that callable, okay? Just thing, so it can make it a function, so the same thing. And then a toString, so just print and you can format it, fine, some kind of overloading. All right, coroutines. Okay, this will be important because when we actually start working on the game, we will need to see well, to do some kind of thread management, right? As in the Solar 2D getting start example shown, say when you're loading some audio or loading some video, loading ads, I think the example was, you want to load it in the separate thread, not blocking the UI. My guess is the Solar 2D is already doing that for you, but I can expect some similar things will need to be done. Say for example, in nowadays mobile games, it's very common that you create a shell and then so that can be installed quickly to the device, and then when you start the device, you start loading all the actual game, right? So that probably would able to use some kind of threading implementation. So let's go over this part. So coroutines are collaborative in nature, which allows two or more methods to execute in a controlled manner. With coroutines, at any given time, only one coroutine runs, and this running coroutines only suspend its execution. Oh, so this is not parallel execution. So it's just context switch. Let's assume we have two methods, one in the main one and a coroutine. When we call a coroutine using resume function, it start executing, and when we call yield, it suspend. So it's really just a context switch. Again, the same coroutine can continue executing with another resume function call from where it was suspended. This process can continue until the end of execution of the coroutine. So it's kind of doing some incremental work. Okay, so it create resume running. Okay, executing coroutines and get the status and wrap. Also create coroutine, but instead of returning the coroutine itself, it returns a function that when called resumes the coroutine. Okay, suspend the running coroutine. Okay, that's fine. So because of the nature, we'll probably skip this session because the code is doing some create and you and you work. That's okay, but not particularly interesting for now. We use the resume function to start operation and so on. We can skip all this and also skip this example. So let's go to the next one. File IO. So this the IO open. That's fine. We saw that already. RWA is append. R plus read and write, and all write data is removed if the file exists. So and A plus. How about the star A? Because I recall there is a star A in the Solar 2D example. Append with read enable and so on. Okay, so nothing much interesting. Just doing that. Okay, this set the uh, IO to that file, and then you start reading and close and so on, right? So in general, in the game programming, at least for now, since we are using the Solo 2D, likely we don't have to use this heavily, because the composer, the Solo 2D system should handles a lot of this already. We do use the IO to read the JSON. I recall. Yes, that was the example. It was saving the high score into a JSON format. But besides that, it should be okay. Oh, there you go. So it return all the content of files from the current position. So that's what we got when we were doing a write. So let's quickly take a look. In the above example, you can see how the implicit descriptor work with file system using IOXF method, read and so on. So you can read from the current file position and return a number. So return a number to mean the file size, the remaining size. This remaining read the content, read just a line, and this read the number of bytes. Okay, and you can do a create. Oh, this have a temp file built in. Okay, so it have this system built in. Okay, interesting. File, close file or null based on the input file. Okay, so it doesn't exist, then it return null, and or it return file. But what's the type? No, not really sure about that. But we don't worry too much about this right now. And also this is file descriptor getting additional information. We don't have to worry about that. So let's skip over on this one. Error handling. So that's important. So error handling is quite critical since real-world operation often require the use of complex operations and so on. So syntax error, of course, is just die. Right, and then this is expect do. So the for do is missing things. So this is missing an input, right? So and then when it run, it do it get a runtime error, right? So that's fine. There is a assert method to report certain message. All right, so that's okay. So let's take a look at these p call and xp call. In order to avoid throwing these errors and handling errors, we need to use the function pcall and xpcall. Call the request function in protect. So protect call. If some error occurs in function f, it does not throw an error. It just returns the status of error. So kind of like a try catch, right? Yeah. What is the error though? What do we receive? You say it returned the status of error, or probably is a number, or actually it's a string over here. Let's do a quick run on this. So if we execute, of course we should see failure, and if we say local v equals to that, v print, well, failure v. I keep pressing save. Execute. It return false. Return false. Okay, let's say a b. Right. Return a plus b. equal 1, like that. What's the error? It also just returned false. So I thought you're going to return the error, return the status. Well, it just says status of error. It's just true or false. That doesn't give us too much information. And this, the X one, will you can provide the error handler. So this is still return a false, but here that's when we accept receive the error. So that is definitely probably what we will use most of the time. However, how to pass information over? We have to wrap it. Okay. So this is calling that. So also let me put A and B over here. Return A plus B. And then now I cannot use this function, right? Of course, if I do this, it doesn't make sense, right? So seems like then I have to do a enormous function. Let's just do that like this. Oh, no curly bracket. Turn that and end. Execute. Right. Why is, yeah, there you go. Right. So you need to do that true. How about this? It's true, but how do I get the value back? Local v and v equal and print b. B is b. Okay, that's how you need to do it. Is there other way to do this? Because this is messy. Of course, we can wrap it around and do something better. That means we will have quite some fun when we actually start coding. Okay, so that's error handling. Debugging. I'll skip the debugging part and we can come back later on. Well, the only thing is there's a trace back to get the stack trace, and those should be sufficient. We can come back to this when we need it. We don't have to go through them now. Garbage collection. Collect garbage. Interesting. We do have some control over this. On this, I would say I will stay away from it. It's already proven that the garbage collection shouldn't be handled by developer, right? And if say for example, for myself, I'm getting more interest in Rust. We don't really need garbage collection, but for other language like in JavaScript using Node.js, or in the browser, or other languages in C# and Java, there's the garbage collection, and it's a very sophisticated piece of work. And manually controlling garbage collection is almost guaranteed to be a failure. And that's why I would say probably shouldn't do it. And I can understand Lua have this because it was written a long time ago and it was based off C. So it's probably the language designer start Lua building on top of C and want to add a garbage collection, and back then you think it is a good idea to have control about the garbage collection, right? But man, I would say generally don't touch it. So okay, cool. Now, we are in the advanced topic already. So what's the time? So just half an hour. So we skip through those, and we are actually here. We are in the Lua advanced session already. So let's see if we can get through to the game programming, and then we can just start running. Okay, so OO is one of the most used programming, yes, but also overrated. And yes, with all this fine feature of OO, we have class and objects, inheritance, and encapsulations, which actually not necessary just in OO. But that's that. OP in Lua, you can implement object orientation in Lua with the help of tables and first-class functions of Lua. By placing functions and related data into a table, an object is formed. Not really sure about that statement. Excuse me. Oh boy. Yeah. I can say a lot about that, but this is not that kind of video, so I will control myself and move on. Inheritance can be implemented with the help of metatables. Yeah. Providing a lookup mechanism for non-existent functions and fields in parent objects. So you can see, say for example, the thing, right? When the object, actually, speaking of that, let's go back to here a little bit, because we take a look at the live demo in the new index when we see the interesting behavior over there. And then let's take a look at this. Right, let's take a look at this. So when we execute this, get the metatable value, that's fine. But if I say my table key2 equals to bra, and it does override it with bra, right? So this can be seen as kind of really setting some default value and so on. So, or the basic initial values for the quote unquote base class. Of course, it's a meta table, it's something else. But that's the behavior, right? Okay, so that's that. It's just how the language work, right? So let's continue. Right, so this is a kind of like what I say, non-existent functions and fields in parent objects. So as you know, yes, you can think about that as a parent object. So this is actually look a little bit more like prototypal inheritance than classical inheritance, which is fine, completely fine. But it is what it is. So that's how it behaves. So tables in Lua have the features of object like state and identity that is independent of its values. What does that mean? Well, let's continue. Let's see. Two objects with the same value are different objects. Okay, whether an object can have different values at different times, but it's always the same. Okay, that's basically not talking about anything, just basic OO. Like objects, tables have a life cycle that is independent of who create them or where they are created. What it means is talking about reference count. Makes sense. And then the concept of object-oriented is widely used, but you need to understand it clearly and for proper and maximum benefit. So let's consider simple math example. So for this one, let's slow down a little bit, go through all of them because it's important, right? Is a important concept to grasp, especially in the new language, at least to me, to understand how they does things. At the end, I might just still go more functional like, but we'll see. So the shape can have, okay, we often encounter situations where we work on different shapes like circle, rectangle, and square. Not good example. The shape can have a common property area. Yeah, it's a bad example. If you know what I mean. But let's play along. So we can extend other shapes from the base object shape with the common property area. Each of the shapes can have its own properties and functions, like rectangle can have property length, breadth, area as its property, and print area to calculate area as its function. Okay, so a simple class implementation for a rectangle with bra as shown below. So we have area, length, and breadth, so basically width. So this is just derived, quote unquote. So you create a new rectangle object by passing in the O, a new object, and length and breadth. And so, okay, so this line is interesting. So this line is basically showing it's very similar to JavaScript, that the OR is actually just returning the value, not a binary operation. When they compare it, it's actually if this exists, it return the O. If not, it return the empty object, not false or true, right? Is pretty convenient if you know what it does. So this set meta table and then set the self, so the base class over there as the meta table, and the self index to self. So why the self index to self? I really like feel like the first thing I come up with is the underscore poto property. My guess is after the same idea, but that is a part that I'm never good at. So let's continue play along. So you get the length and default to 0 because over here you can set a default param, and then it calculate the area and return the object. Okay. So and then the rectangle do a print area and with the self.area. All right, but it haven't described the difference between the colon and the dot yet. Hopefully it would do underneath. So creating an object is the process of allocating memory for the class instance. Each of the object has its own memory and share the common class data. Okay. So this passing a new in there, which will get this. Of course, you can also pass the object and override things, which, well, but the length and breadth does nothing because it will being overridden. So there are some pretty messy thing can go on. So accessing properties, we can access the properties in the class using the dot operator. So yes, that makes sense. And the member function using colon. The memory get allocated and initial value are set. The initialization process can be compared to constructor in other OO language. It is nothing but a function that enables setting values as shown above. Okay, that's it. That's what it would talk about. Okay, let's take a look at the example. So have an area and then create new side. What are you trying to create? It's a square. Yeah, that's why it is a bad example. Okay, print area, new now, print area, print square. Okay, yeah. If you, by the way, if you're interested, you can just Google OO rectangle and square and shape example, and then probably there's something will come up describe why it is a bad example. It's a well, actually I shouldn't say it's a bad example. It shows that it is a why the is a concept for OO is completely flawed. That's not what OO is really about. But in the future I might talk about it. But for now, let's move on. I try to behave myself. So let's get going. So inheritance in Lua is the process of extending simple base objects like shapes to rectangles, squares, and so on. Is often used in the real world to share and extend the basic properties and functions. So get the area, you create new, you're done, print area, we have that actually a square. We extend the shape to a share class. Yes, when what? Okay, so it's wrong in so many places because you are creating a new shape and then now it's square because you implement it as a square. Okay, so yeah, what is this? Yeah, so this is essentially still, this is just calling the base constructor to create an object and then do this set, right? So essentially this combine is really kind of like the object create or the old time JavaScript prototype inheritance that you set the proto or declare the set property set prototype of function. So it's print. That's what that is. All right. So not going to control. Overriding base functions. We can override the base class function. We can override the base class function that is instead of using the function in the base class, the derived class can have its own implementation. So you just set that up. The reason is this kind of, well, I assume is this, because the index, as we just saw, when you create the same property in the derived class or the actual table compared to the meta table, the actual table wins, right? We get that. And so that's how you define a override method. But you don't have any checks that, you know, the number of parameters have to be the same and all that. So list scope substitutions would be a problem, and need to be careful about that. And the language does not help you in that regards, as far as I can tell so far. Okay, so this is a full example, don't care about it. And all right, that's it. That is OO. So it also is just talk about the, or didn't really talk about it. It's just say, oh, for method using the colon. Okay. So there are some MVC framework with all this. Yeah, we're not doing that, so we can skip over. So let's skip this. And database access, we don't need database access either. Maybe except SQLite, right? But again, we don't have to worry about it as of now. Game programming, Corona SDK, which is Solar 2D, and so on. So we have all this API. Okay, this is just a introduction of all those engine. So yeah, we go through the whole thing. Have 10 minutes left. So instead of jump right into it, let's take a quick look if there are any interesting thing here in the standard library. So let's see, basic library. We have the basic library throughout the tutorial, error handling. So let's take a look at that. And let's close this. Need for error handling. Okay, we just go back there. So it's nothing. Memory management, the garbage collection. Do file. What? Okay. Do file. It open the file and execute the content of the file as a chunk. If no parameters is passed, then this function execute the content of standard input. The error will be propagated to the callers. So it's kind of like execute. So process dot exact. Okay. So the super global get f env. So get the current environment in use by the function. F can be a lunar function or a number that specifies the function at the stack level. Level 1 is the one is calling, so kind of the stack, going back up the stack. It's a pretty bad idea to do that, by the way. If the given function is not a Lua function, or if it is 0, given return the global. What? That doesn't make much sense. Oh, it go downwards. Oh, it go down. So 0 is always global. 0 is always global. 1 is you. And then probably 2 is your parent. 3 is your grandparent, and so on. And then somewhere that will go back to global, I guess. Okay. Get meta table, I pair. It doesn't show the pair. Oh, there you go. Suspend the running coroutine. Oh, the parameter passed to this method add as additional return values to the no. This is incorrect. It's the same description. Yeah, so oh no. So it's the one that I want to know, but it's not described. So seems like a lot of this, probably, yeah, probably we skip those, because until we need it, we will get more into it. There are some strings, table manipulations, and so on. Yeah, and then some math functions shouldn't be too surprising over here. And well, we'll look it up when we need it, so we don't really have to go over it for now. So what else do we have here? Operating system facilities. So clock date different execute, exit, something, simple stuff. Delete the file. Gonna be inside IO because we have an IO file, IO open, right? But oh well, seems like it there. And that's about it. All right, we have finished, essentially finished the whole Lua tutorial. So let's take a break and end this video right here. And in the next one, we will actually get starting. So stay tuned and we will see you in about a couple minutes actually. Bye.